Hello everyone. So for today's class, this is a session 3 for week 3 for environmental geomechanics course. So before going ahead in this series where we'll solve the previous year assignment questions, uh, we'll try to look back at what was taught in these in the four lecture that is assigned for week 3. So in these four lectures, the major topic is first, Sir has discussed about the importance of nuclear nuclear power, for example, uranium as an energy source compared to coal. The second thing that he discusses about the carbon sequestration. Then he also look upon the gas hydrates and discuss the why soil is a living entity. So we try to look at recap all of these topics and see what we got to learn. So before we move into the next one, which is about the topic which is carbon sequestration. Uh, before that, Sir discussed how uranium or the how nuclear power can be used for generating energy, and is it a better and cleaner source compared to coal. Now, and the amount of waste that is generated by uranium or any other uh, actinoid series element actinoid is less compared to the coal. Now, all of us know that after COP26, it's kind of target that everyone has to shift their energy towards the carbon neutral, towards more carbon neutral society, right? So to the path to the carbon neutral society is either we fixate on the renewable energy like sun, wind energy, or water, or we can go to this nuclear powers. But the point is, many of the scientists and they say that many are on the favor of only renewable energy, and some of them are in the favor of using nuclear power as a energy source. Now, the reason that nuclear power is not used as vastly compared to the renewable energy is because uh, there is a lot of harm towards the nuclear power. One of them is that radiation. So even if the waste that is generating or the byproduct of using uranium for energy is less or is small amount, but the amount of radiation over time is huge. It's large. It will affect a larger population. For example, and while generating the energy, there can be mishaps. For example, Chernobyl, right? Another thing is that people or the nations can use nuclear power for their own purpose, own agendas, compared to using it for a better environment or a cleaner environment. That is the one thing that Sir has discussed in this series. Another thing that is discussed is a carbon sequestration. So, what we understand by carbon sequestration is we capture, it's a process of capturing and storing the CO2. So, we have CO2 in the atmosphere in the gaseous phase, we capture it and we convert it, like either we change its phase to a more sustainable phase, and we store it in different places or in via different methods. So this diagram is about the different options that can be used or are used for carbon sequestration. So one is the terrestrial sequestration. It means we have plants, so there is a lot of afforestation going on in some areas where, and people say that plants are important because what they do is they take your CO2 and they convert it into better form, or they use it for their food and make and lead to organic matter, right? It's a better form of carbon compared to CO2. Now, that is why afforestation or farming or agriculture is a good source for carbon sequestration. Another source can be chemical conversion. In it, what happens is, let's say we have any oxide. One of the method is you take a oxide, for example, calcium oxide or magnesium oxide. You react it with CO2 from the atmosphere, and what it forms? It forms either calcium carbonate or magnesium carbonate, right? So you are taking something which is gaseous and converting it into a chemical which is solid. So there is a phase transition of CO2 as well. Why? Chemical conversion. And these chemical can be used in our daily lives as well as they can easily be utilized. Another, a very important method of carbon sequestration is that power stations or they capture CO2. And other thing is the companies like oil companies. What they do is they take CO2, which is in gaseous phase, they compress it and they pressurize it to make it into a liquid CO2, right? And this liquid CO2 then is passed to the ground, and the cracks are filled, right? And so in the oil companies, how it is beneficial is that for example, this is a land, and so generally what happens is that soil are the oil is generally collected in this dome shape like structure, and then you put a pipe and this oil will come out, right? But what if we have utilized a lot of already utilized oil from this basin? Now the oil present is very less, but how is it present? It is present in the pore space, right? That is how you are getting oil in this dome shaped structure as well, because the pores are completely filled, and then it start oozing out and makes this reservoir which we are utilizing for our oil needs. Now if in these pore spaces, let's say these pore spaces are not connected and oil is still there, but there is no means that we can get this soil. So what we'll do is what we do in this case, the oil company do is that they inject liquid CO2 into the soil. So when you inject liquid CO2 in the soil, what happen is this CO2 occupy the pore spaces and hence remove oil from these pores. Now when the oil is removed from the pores, what happen? It comes to this area and you can extract it. So the oil companies, for example, ONGC and other Oil India Limited, these companies are utilizing this carbon sequestration technique to enhance the recovery of the soil, because you take CO2 which is in gaseous form from the atmosphere, you convert it into liquid form, you transfer it or inject it into the reservoir where you have any oil, and then what this CO2 do is it occupy the pore at this oil, right? The other important thing that sir has discussed is about the gas hydrates or ice clathrates. So what does clathrates are? Clathrates is nothing, is just if you have two components, and let's say this is a lattice, okay? So one component is making the basic structure and the another component is occupying the pore space. That is what clathrates are. And because it's the gas hydrate is in the form of ice, or this lattice is basically water lattice. Um, so this is ice clathrate. So a lattice or a structure of one component where the pore spaces are occupied by the other component. So gas hydrates are nothing but crystalline solids, and they consist of methane gas surrounded by water molecule. And sir has also discussed that this gas hydrates contain up to 180 meter cube of methane. So one molecule has a very high concentration of methane, and that can be utilized for the energy purpose. Now there are this topic has been explained in like very depth, and we'll look into all of those things that sir has discussed. So one of the question that come is that what are the different sources of methane? So in the lecture sir has discussed two sources, right? One is the biogenic, another is thermal, yeah, thermogenic. So what do we mean by biogenic and thermogenic is, uh, in biogenic, it's 1 second. Okay. So in biogenic, basically methanogens. If you have heard of this term called methanogens, methanogens are nothing but bacteria that generate methane. So what happen is along the coastline, there is clay material and also lot of biota, right? Lot of dead plants, dead zooplanktons are coming towards the edge. Now what these methanogens or bacteria, methane producing bacteria are doing is they are disintegrating or decomposing this zooplanktons and other things to make methane. Another is thermogenic. In thermogenic, what is happening? If you have heard a term called kerogen. So, what is kerogen? It is nothing but organic material which is found at very high or very deep inside the earth crust, and it's basically an insoluble material from which all of these natural gas or petroleum products are formed. So what happens is that over time plants and animals are dying, and they decompose, make kerogen. This kerogen again do this kerogen again undergo reactions, and after undergoing different reaction produce hydrocarbons and natural gas and methane as well, right? So thermogenic is basically, if you look at both of them, it is happening at way shallower depth compared to thermogenic. And also there is a temperature difference because this is happening deep. So the temperature that at which thermogenic methane is produced or is released is higher temperature compared to this, where the temperature is of this biogenic methane release is lower. So these two sources of methane is being discussed. Now the another question that come is how people or how the agencies extract these methane gas hydrates. So we know that CH4 hydrates are at high pressure, right? And they are at high pressure, and because their ice clathorate, it means that they are of low temperature. So what are the two methods that can help in extraction? One of them is depressurization. So you are releasing pressure from the top of these methane hydrates, and it will start coming out. Another is thermal simulation. It means you are increasing or you are providing uh, temperature at depth, which leads to escaping melting of the ice, and hence escaping of these methane, right? Now, these two methods that's discussed, one is depressurization, another is thermal simulation. There are a lot of challenges involved with this. So what are the challenges involved? First is, if so we know that methanes are is present in the pore space of this whole lattice. Now if methane is releasing from the pore spaces, what is happening? The pore is getting empty, so all the fine material around that area or around it, that zone, will start entering into the pore spaces. So there is movement of fines or fine particle. Second thing is subsidence. So why subsidence happen? So in our daily life we also see that sometimes the road got subside, right? In a high like flood like situation, or when there is high rainfall, many of the roads got sunk. Why? The reason is displacement. So if any material from below is removed or is sinking down, what is happening? It is creating a space. So okay, so let's say here there is sediment, and these are the methane hydrates. Now in these pores there is methane. If the methane is released, what is happening? These sediment will start entering these pores. Hence, this area will become empty, and this land can sunk during high rainfall condition. So, subsidence is a normal thing, normal phenomena. Another is that lot of greenhouse gases. So, if during the natural disaster or during man-made influences, if a slip surface is created, slip surfaces when there is movement of two blocks. So if there is any gas, methane hydrate here, it will try to come out of it. So when during any disaster, generally slip surfaces are created, and these slip surfaces lead to the release of greenhouse gases. And methane is one of the greenhouse gases. Now, so this is about the sources, which is biogenic and thermogenic. The extraction methods, for example, depressurization and thermal simulation, and the challenges involved for the extraction. Now, Sir has also discussed that there are different gas hydrate region or basins in India. So these two pictures depict those places. One is KG Basin, which is the Krishna Godavari Basin. Another is Mahanadi Basin. Then there is Andaman Island, and there is Konkan Basin. And the picture here, which is on your right, determine what is the highly prospective region. So we know that Krishna Godavari is a major region of gas hydrate compared to Konkan Basin, right? So these and in there is a recent study on Krishna Godavari, which is one of the most important gas hydrate region in India. So it produces this 180 meter cube of methane. Now let's move towards some of the questions. Okay, so these are questions on densification of soil. So these three questions are similar. What do we mean by densification? Densification of soil means that you are increasing the density of soil. So let's first discuss all of these methods. So what do you mean by drying? Drying means that water expel water is expelled from the system, right? Generally, for example, during so if in a house which is not like well taken care of, what happen is on the wall of that house generally cracks start forming because of constant sun, right? So drying is when due to constant high temperature the water expelled, so it leads to formation of cracks in a soil. Another is swelling. So, do you think drying leads to density? No. So, it does not uh, increase the density of a soil because it. Okay. So, increasing density means increasing the volume, and decreasing the volume means that reduce the void space. So drying, even though it leads to removal of water, it forms cracks. And cracks means there is void, there is space in the soil, and hence density will be low. Next is swelling. Swelling is nothing but inducing water to the system. So if you induce water to a soil, what happen? All the pore spaces are filled with water, and in this case there is no reduction in the volume, hence low density again. So swelling and drying cannot lead to increase in density of soil. Next come consolidation and compaction. Now these two, both of these methods are similar, or they seem similar but they are different. In what sense? Consolidation means, so in both of these method you are decreasing the void, right? So voids are decreasing, but what is happening in consolidation, though it only happen in saturated uh, soil. So a water saturated soil can undergo consolidation because in that water is removed and the density increases because voids water is removed from the void. The soil particle or the loose soil particle occupy that pore space, and hence it enhances the density. In compaction, what happen? It only happen in unsaturated or partially saturated soil, because in this either the void should be occupied by air fully or partially. So compaction is when you remove air from the system and the voids are occupied by the finer grains, and hence increases the density. So both in consolidation and compaction, the voids are either in consolidation voids are filled with water, in compaction voids are filled with completely or partially with air, and what you are doing is you are removing that media, either water or air from the system, and hence the finer grains of the soil enter into the void, making it compact when you apply pressure, and increasing the density of the system. So both of these are used for the densification of soil. Now this question is about compaction. So I just said in compaction it is all about air, not water. So compaction is when you remove air from the system or from the soil. This question is about so which of the following statement is correct. So we go through each statement and then we'll see that which is a true statement or which is false. So now first is compaction increase density and void ratio of the soil. So if the compaction is lead to removal of air, what it does, if air is removed, the volume decreases. If volume decreases, then density increases because density is mass upon volume. So in compaction, voids are decreasing, density is increasing. So density by void ratio is what? High, and hence it is true that compaction increase the density. So this statement is true. Another is compaction of granular soil might lead to particle crushing. Now, do you think that uh, s- if a geo mechanics engineer know that compaction leads to particle crushing, do you think that we'll do it? We will not do it. So it, but if we still do compaction as a process of densification, it means that this process or the compaction does not lead to particle crushing. So it is a false statement. Another is about expulsion of air from void lead to increase in dry density. Again, yes, expulsion of air increased in the leads to increased density. So it is again a true statement. Last is that for different moisture content we have same dry density. No, because with change in moisture content the density changes, because with change in moisture content volume changes, and volume changes it means density changes. So again it is a false statement. Okay, now the next is about byproduct of coal based electricity generation. So we know that in India, majority of the power or the electricity generation is still on coal, along with of course hydrothermal as well. But coal is used for electricity generation. So what are the byproducts, and which of this is the byproduct? Now let's discuss each of them and then we'll decide. First is the coal washery residue. So what is coal washery residue is when we extract or when we excavate coal, right, from mine, it is not pure, right? It has along with the coal it has some amount of sediment or some amount of organic matter attached to it. So what we do is we have coal washery where with the help of water you remove you dip this coal into, let's say, for example, we have a drum filled with water. You dip coal into this water. What happen is these impurity will settle down first compared to coal. So coal will also settle down because it is denser, but the sediment and the organic matter will settle down first, and we can we get the clean coal which we can use for energy purpose. So this sediment and organic matter and this water is called this coal washery residue. That when we washed our coal, whatever is left with in this water, sediment, organic matter, any other element that get excavated during it, is basically coal washery residue. So it is a byproduct. Another is fly ash. So what is fly ash? It's a, in simple term, it's carbon particle. So you are burning coal. When you burn coal, it cannot, it is not completely burned. Okay, there is incomplete combustion. And whenever there is incomplete combustion, you release fly ash, you release that black powder, which actually is very harmful for the health as well, into the air. For example, the simplest example is this also happens in chimneys. When you burn wood or anything, you also release this particle like structure. So of course fly ash is also a byproduct. Now overburden. What is overburden? Let's say this is a mine, right? This is a wall, this is mine wall, right? Now you start excavating from here and you start making ways and you are removing material from here to make a this dome like structure which is completely empty from inside. Now this material that you have remade, so this is uh, so this material that is, when you are making this space in the mine and you are removing coal from it, this the surrounding sediment, okay, any soil, rock, etc., that you are removing during the excavation is basically overburden. So whenever you excavate or whenever you are extracting coal, you are making this cut in the grounds, you are removing soil and rock, and then you are getting soil, then you are getting coal. So all of this soil, rock, or any other residue is basically overburden. So of course overburden is also a byproduct, and the answer is all of these. Okay. The next is about the surface area or specific surface area. Specific surface area is nothing but surface area per unit mass of soil is specific surface area. Now the question is that of all of these, which exhibit less surface area? So if we say the surface area is basically directly proportional to particle size. So this image or this picture comes into play. Let's see where is sand. So we have sand here, then silt, and then clay. So we know from sand, silty clays to clay, the particle size is decreasing, right? So clean sand has the largest particle, it means lowest surface area, and clay with high plasticity has is of smaller size, it means high surface area. So I can say that from sand to clay, what is increasing? Surface area is increasing. So it means that which of this has less surface area? Sand. Because sand has larger particle size compared to silty clays or normal clays with high plasticity. Okay, so after this, the last question is here. This is about the interface. Okay, so this is a match the following question, and we have given different scenarios, and we need to define what are the interfaces at each point. So first is about the pipeline and soil mass. So let's look at, so pipelines, it can be oil pipelines, it can be gas pipeline, but pipelines are what? They are solid, and soil is also solid. So it is a soil media. So this is one, right? Another is salt water intrusion. Now what is salt water intrusion? Let's say we have a aquifer here. This is sea, we have a aquifer. This is a well. So, and this line is basically partition between the salt water and fresh water. So when uh, so what is happening is that when the well is new, it means you are not extracting lot of water from that well. This demarcation between salt water and fresh water is there. Okay, so at this time or the new well, if you extract or if you take water from a new well, what it is giving is fresh water, because it's still uh, in the this well is still in the fresh water zone, right? But if during the old well, what happened is, if we become so greedy that we are continuously using this well without recharging the aquifer. Recharging aquifer either using rainwater can be a method, artificial recharge can be a method. So if we are not recharging the aquifer, we are just using it, what happen is the water table starts sunken down, and this salt water layer, it start coming upward, because fresh water is no more, right? And since fresh water is no more, it is taking the space of fresh water. So this is salt water intrusion. That is, if a aquifer is not properly recharged, what happen is this the salt water, the fresh water start decreasing, and the salt water start taking its place, and hence this process is salt water intrusion. But you see where it is happening. It is happening between a liquid and a liquid interface. So the answer for salt water intrusion is liquid interface. Now another is carbonic acid preparation. So if we know the how the carbonic acid is formed, so the reaction is, we have CO2, we have water, and it leads to what? H2CO3. So even though carbonic acid is a weak acid, what it is taking? It takes a gaseous CO2 and convert it into what? Uh, it could be into liquid, right? If it is happening because it is coming down, let's say via rainwater, so raindrop. So it is converted in a gas into liquid. So this is a gas to liquid transition. Now we left with the last, with the dispersion of plume in the air. So plume is basically, let's say we have wildfire, or we have forest fires. So what happen when there is a sudden large amount of burning happening? So it means large amount of gas is released because of that burning into air. So these gases are what? This is a gas state, and air is what? It's again a gas state. So the exam, this is fourth. So the answer is third, which is BADC. Okay. So for today, this is the session. If you have doubts, you can ask. So if you don't have any doubt, we can end this session here.